independently this and this. I talked about the accommodation, how it is generated, how it is the sediment is dispersed, and all these things that independently by sequence stratigraphy and the subsidence model, the McKenzie model, and all these models by which I discussed that how the accommodation that is being created in the different tectonic setup of the basin, passive margin, then rift setting, the foldland setting. We have discussed this part. We have also discussed the denudation part. Now, today we will be trying to show you that how these two parts they are clubbed to make a comprehensive basin model. These two different parts they are then clubbed together and form the comprehensive. So what basically in this whole process we have some premise. We have some premise. What are the premise based on which we are doing this basin analysis and clubbing the two components, that is the denudation and the basin holding capacity. These two components we are taking to. So that is actually the what are the premise. So the premise, if we jot down, number one, the premise what we talk about, number one, it is the denudation, the sediment delivery from a province at a uniform rate from, and the province that will be of the mean elevation. That we have a province that is supplying the sediment at a uniform rate, and that province has a mean elevation. Okay, we are talking about a mean uniform elevation of the province that we are talking about. It may not be. Suppose a terrain which is supplying the sediment, it has a hill component and it has a plain component. Then definitely the hill component will supply more sediment than the plain component. But we really do not consider that. We simplify the whole thing and we are considering the entire province from where the denudation is taking place. It is of uniform mean elevation and it is everything is going in a same denudation. That is a primary. Number two, the basin has a uniform dispersal of sediment. And thereby we are thinking that the entire basin, that if it receives the sediment, it will distribute the sediment uniformly in the entire basin, which is again the oversimplification. So it is a uniform deposition in the basin. Why I am telling it is a oversimplification? But because it never happens. Suppose a basin where the river system that is diverging its sediment, forming a delta, that will be receiving the maximum sediment supply from the denudation area. Where the river system is not debouching, there the sediment acceptance of the basin that is much less than where the delta is forming. But when we are doing the modeling, we are thinking that everywhere in the basin, the sediment is dispersing at the same rate. So it is an oversimplification, isn't it? Am I right?
Yes, sir.
So you see that these are because you are doing a modeling. In the modeling, if you put so much of component, then that becomes a very, very cumbersome and you cannot handle that. So we are thinking that there is a provenance of mean elevation, which is supplying the sediment, and there is a basin which is basically collecting the sediment and distributing the sediment uniformly over the basin, which really is a oversimplification. Number three, the sea level is the upper limit of the basin. Okay. Number 4, sea level and tectonics together control the accommodation in the basin. Control the accommodation in the basin. Okay. Number 5, that the sediment which is available by denudation, that is entirely being distributed in the basin. There is no sediment loss in between. That there is no sediment loss in between. Denudated mass balanced by sediment deposited in the basin. Okay, so there is no in between sediment loss. I am not thinking of any sediment loss in between. Okay, so that I can mass by mass, volume by volume, I can balance it. Mass by mass, I can balance it. Number 6, the number 6 is that there may be carbonate in a basin, deposit the carbonate and evaporite that is considered in MCH or DCH. That is the chemical component, the chemical denudation component that may be accommodated in the basin either in the form of carbonate or evaporite. There are two, one is mechanical denudation, another is chemical denudation. So the mechanical denudation part that I have talked about, that they are whatever that is uniformly distributed. And what about the chemical denudation part? The chemical denudation part that will be accommodated by the carbonate and evaporite depending upon whether it is an open basin or a closed basin. I will come into discussion of that. That will be controlled by the chemical denudation part. So all these, that is the premise, or that is the premise of the system. Am I okay? Is there any problem in between?
No, sir.
Okay. So all these are basically my premise. Now, if this is my premise, then how I approach to the model? How I approach to the model? First, let me draw a figure to make you understand that what really I am talking about as the model. Please draw it and then I'll discuss. Can you see the figure?
Yes, sir.
Okay. And you can read it, or if there is any problem in reading, please let me know. I will read it out.
So what is written in the lower left side?
This one,
So left.
within bracket bypass, no deposition, total transport.
So in the opposite side, yes.
Yeah, specific yield tons per kilometer square per annum. Ton per kilometer square per annum. So here it is written MMC, MMC, MCH. That has two components, MBI, MEB. MBI means mass biogenic. MEB means mass evaporite. MMC is mass mechanical. Is it done? Hello?
Yes, sir.
Okay. Now let me explain this figure. What is happening that you have an area where from the erosion and weathering the sediment is delivered. So this is the area of denudation. This is the active elevation and the area of denudation. Now at what rate the denudation we can quantify? We can quantify either in terms of volume of sediment you are generating or in terms of the height of elevation that it's going down, that the lessening of the height of elevation, the amount of height of elevation that is lessening, that is actually it is yielding in the form of sediment. So when you are calculating it in terms of sediment volume it is generated, then your unit is meter cube per kilometer square per annum. So per kilometer square, how much meter cube, that is volume, the sediment you are generating per annum. So that is one way. The other way is millimeter, that means height of the elevation. How much elevation height you are decreasing per kilo annum. So both the way we can actually quantify the amount of denudation, the height decrease or the volume of sediment that is being generated. Is it clear?
Yes.
Yes, sir.
Fine. Now, this area, the whole area from here, now this is the area at the foot of the hill where you are not actually getting any deposit because of the high gradient. Most of the sediment that is being transferred in the downstream. So no sediment is getting rested there, and so it is a zone of bypass and no sediment is getting deposited. This is, I am telling you, this is a oversimplification. Try to understand my thing. This is a oversimplification in the modeling, because in many cases at the base of slope you get the alluvial fan that to be deposited, and the alluvial fan is deposited essentially in the base of slope. But in the model, what I am saying it is a zone of bypass. There is nothing getting deposited. So there are a lot of loopholes that when you are talking about the basin analysis, you must understand that there are a lot of loopholes that is not being considered here. Let me be very clear in these things. No misconception should be there. Okay? Then this sediment that is being supplied, they are considering the entire sediment which is generated here no sediment that is being deposited in the foothills, and all sediment that is being supplied to the basin. That is their saying. That is the supply to the basin. That is their saying. And that is how they are doing the combined modeling of this and this, because of a mean elevation and the all sediment that is being generated from there, all are being supplied in the basin, either in the mechanical or the chemical form. So that means in this entire area, you are not getting any particular deposition, and there is no, but which is really not true. Which is really not true. It is oversimplification. So then you come to the specific yield. What is the specific yield? That means the tons per kilometer square per annum. The river system which is generating, that is supplying to the basin. That is what we call the specific yield. That is the tons per kilometer square per annum. That is your specific yield. This specific yield, as it comes to the basin, the entire area from where the denudation you are talking place, this area is called AB. AB is the entire area that is responsible for the supply of the sediment in the basin. The total drainage area I am talking about. Now, in the total drainage area, this portion is of higher elevation, this is of lower elevation. So, but most, and we are considering all the sediment supply from where? There is no supply from there. But again, we are talking that there is a mean elevation, which is not true again. Okay, and this area we call it the AB, and this area, the basin which is receiving the sediment, that's you call as a AD. Now in the AD, what you are getting? You are basically getting the mechanical sediment to be deposited and the chemical sediment. Okay, so the mechanical sediment, that is MMC, and the chemical sediment, they either in the form of mass biogenic, that the carbonate build up, carbonate sediment, which often becomes the bioharm, which often becomes the reef, and that is very localized structure, not fully deposited, that get deposited, that, or in a closed basin, if you consider a closed basin, that the evaporites may be deposited, which is also consuming the cations, Ca, Mg, Na, all these the cations that they consume. So the chemical sediment, they are either the mass biogenic or the mass evaporative. Now this is, so what will be the DMC? DMC, that will be the specific yield, the AB by AD. That is what is DMC. So SOI is DMC, AD by AB. This will be the specific yield. Okay. Now, in this entire modeling, what is important, that the volume of sediment that I am getting from here, that volume of sediment, that in terms of the entire volume, the mechanical part and the chemical part, the combined volume which is being released, that combined volume that is being accommodated here. This is what we are saying. Now, suppose here there is granite, there is sandstone, there is any kind of rock, and then the feldspar get disintegrated and it releases different kind of cations, it forms the clay and all these things. Now, when the entire cation is coming here, it may be accommodated in the form of a carbonate, in the form of a evaporite, or it can be deposited in different forms. So there are two different kind of lithology. Here there comes some kind of lithology which is supplying the sediments, supplying the cations, supplying the anions, utilizing those sediment and the cations and anions, some different kind of rocks that is being deposited. And when it is being deposited, suppose in case of a mechanical also, they are deposited with different kind of porosity. When they are deposited as a shell, when they are deposited as a sandstone, all the porosities, they are not same. So there are two types of variation when you are modeling. So ideally you are taking this and taking this, and you are modeling. So you must understand that the rocks what you are considering here and the rocks you are considering here, these two are not the same type of rock. So their density varies, their porosity varies. Density varies and their porosity varies. Now, how you will be accounting when you are doing the mass balance, when you will be doing the mass balance between the two, then how this density and the porosity factor that must be taken into account for the final basin model. Is it getting clear what I am saying? Or should I repeat it again?
Sir, please repeat it.
What I am saying that I am finally what is my motto? My motto from the very beginning of the class, I am trying to say that it is actually a mass balance model that we are aiming at. Mass balance. How and for that mass balance model, we are doing a lot of simplification. We are considering the mean elevation of the denudation area. We are considering that the uniform distribution of sediment in the basin. All these are oversimplification. Okay, and we are trying for a mass balance. Now, when you are going for a mass balance, then there must be the rocks of the same density and rocks of the same packing structure, because you are doing the mass balance. Okay, but the thing is that the type of rock in the provenance, suppose in the land area, what we are getting granites, we are getting sandstone, we are getting igneous rocks, you are getting basalt, diorite, and all the gneiss, all these different kinds of rocks which are going to the weathering profile. And that weathering profile, the feldspar content, the ultramafics, the olivine content, the pyroxene content, the mafic mineral content, they are unstable minerals and they are going to the weathering profile. And in the process, they are not only create the mechanical sediment, but also release lot of different kinds of cations and the anions in the water column, which are being carried by the river system into the basin. And in the basin, when they are reaching, again, there are different kind of rocks, that is a carbonate, evaporite, and all these, they are accommodating that cations and the anions, which is being brought by the river system from the weathering profile on land. Now, when I will be doing the mass balance, then on one hand, I have the granite, gneiss, diorite, and all these kinds of rock. On the other hand, I have the carbonate, evaporite, chart, all these different kinds of. So two different kinds of rock. I am trying to balance the total mass and the total mechanical and the chemical constituent of the weather mass and how they are distributed in the basin. So when I am doing that, suppose the Himalaya and the Bay of Bengal, that the Himalaya is being weathered and the entire sediment and the entire cation anion that is being supplied in the Bay of Bengal. And that what is happening in the Bay of Bengal or in the Arabian Sea, you either getting a delta, you are getting the reef structures. If you go to the Arabian Sea, the Bay of Bengal, the reef structure, the carbonate develop, the coral reefs, all these different kind of different lithologies that is being formed. How we then model, without taking the effect of rock density and the porosity, we have to take into account the conversion factor, which is related to the porosity and the rock density in the entire modeling. Am I clear what I am saying?
Yes, sir.
Okay. Now, I will tell you how really we do it. How really we do it. First draw it, then I will tell you. Are the figures clear to you? Hello? Yeah. These two figures needs little change. Are the figures okay with you?
Yes, sir.
Okay.
So what is written after sediment? The above.
Sediment deposition. This is conversion factor, porosity, rock density, denudation, conversion factor, FD, that is FS.
So in the mid part, what is written?
SY is equal to 1. Specific yield. Specific yield is equal to 1. That means the amount which is, what is specific yield is equal to 1. The amount that is denuded, the same amount is deposited here. That means the specific yield is 1. Is it drawn?
Yes, sir.
Yes, sir.
Okay. Now I am taking a case with dr, that is the denudation. Dr equal to 2. The porosity of the depositional sediment. Dr is here. That is in the continental side. The dr, that is the denudation rate, is 2. What is dr? Denudation rate. Am I clear? Please clarify if something is not clear to you. Denudation rate is 2. The porosity of the deposited sediment here, this is 0.4, and the density is 2.6. Density is 2.6. The denudation rock ka jo density, that is 2.6. Then I will be identifying that what will be the amount of sediment that will be deposited if the depositional porosity is 0.4. If I consider the depositional porosity 0.4, then what will be the deposition in the basin if denudation rate is 2 and the denuded rock has a density of 2.6? Am I clear?
Yes, sir.
Sir.
Fine. In that case, first we have to determine the specific yield. What is specific yield? Specific yield is dr by, now we are saying that the density is 2.6. So the density, if it is 2.6, the corresponding, the conversion factor is 0.385. So dr by corresponding factor related to 2.6 density. What will be the 2 into 10 to the power 2 divided by 3.85? 3.85, because it is multiplied by 10, and that will be 5.2 tons per kilometer square per annum. That will be the specific yield. Am I clear?
Yes, sir.
Fine. Now, what will be the sediment that will be deposited here? Now the question of specific yield mil gaya. This is the specific yield. Now we will go to find the Vs. What will be Vs? What will be the deposited? So Vs will be 5.2 into 5.2 into the corresponding factor related to the porosity, that is 0.63. 0.63 into 0.63 meter cube per kilometer square per annum. So what will be this? If I multiply 5.2 by 0.63, this will be 3.3 meter cube per kilometer square per annum. So if you make a denudation of a rock of 2.6 gram per cc at a rate of that is the 2 meter per annum, that kind of denudation, that will be depositing a sediment of 3.3 meter cube per kilometer square per annum in the basin. Am I clear? Hello?
Yes, sir.
It is clear?
Sir, in the equation it will be 10 to the power 1, not 2.
Which one?
That dr sy when you were solving that equation. Because you are multiplying with the 10, then the power will increase by 1, not 2. In the right hand side.
Which one?
Sy.
dr by corresponding factor. So it is both above and below, it is being multiplied by 10. What is the problem?
So it should be 10 to the power 1, not 2.
No. This has been multiplied by 10 and used it. I am not using. It is already multiplied by 10, na?
Alright, so then what is the second part that you solved?
This is 5.2. You got it?
Yes, sir.
5.2?
Yes, sir.
Okay. Then 5.2 that is multiplied by the conversion factor which is connected to the porosity 0.4.
Okay.
Because I have given the 0.4, the porosity. Okay?
Okay, sir.
Then it is multiplied by that factor to identify the Vs. Okay? Now, if we do it just reverse, we try to identify the denudation rate from the Vs value. Am I clear?
Yes,
Hello?
sir.
Yeah. So now I am saying that Vs is 25. The porosity N is 0.6 and rho is 2.4. 2.4 rho, 0.6 porosity. I have a 0.6 porosity and the sedimentation is 25 meter cube per kilometer square. Okay? I want to know what will be the denudation rate if the density of the rock I consider 2.4. What will be the denudation rate? So here again you will be identify SY. Here it is Vs by what is the 0.6, the 0.9, 0.9, the 0. So 25 by Vs by 0.9. That will be the SY. Am I clear? Hello. This is
Yes,
just a back exercise I am doing. Hello.
Yes, sir.
Yes, sir, it is clear.
Yeah. So it will be 27 tons per kilometer square per annum. If you divide 25 by 0.9. Then what will be the denudation rate? The denudation rate will be 27 into, then you come to this density 2.4. So this is 0.417. Okay? 0.417 into 10 to the power minus 2. Sorry, it will be 4.17, not it is 10 times multiplied. It will be always 10 times multiplied. Then if you do it, this will be 1.1 centimeter per kilo annum. Is it clear? Hello. Hello.
Yes, sir. It is clear.
Okay. So this is what we call the steady state model. We call it steady state model. Steady state model. So how you are basically doing a steady state model? That you are basically considering the rate of denudation, the rock density, and depending on the volume of sediment that is being deposited and its the depositional porosity. So if you consider this, then the balancing between from the sediment budget to the denudation rate or to the denudation rate to the sediment budget. So what will be the amount of sediment, suppose for 10 kilo annum or 100 kilo annum, what will be the sediment that will be deposited in the Bay of Bengal by means of denudation of the Himalaya? If you know the average elevation of the Himalaya and you measure over 100 kilo annum that the elevation of the Himalaya, mean elevation of the Himalaya, how much it is changed, then you can model that how much sediment you have deposited in the Bay of Bengal. Okay, this is what is called the steady state model. I think I could tell you the essence of the thing, if you can understand that. Could you get what I was trying to, I was shouting for so many days? Is it clear a little bit or it is not clear? और नहीं तो एक असाइनमेंट करोगे इसमें, तब थोड़ा क्लियर होगा. Hello?
Sir, in this analysis, the porosity and the rock density value that we take, it is different for the different rocks. So that's how
it
we
is
get.
different for the different kinds. Suppose that deposition.
So how many how many analysis do we need to take for this?
No.
Steady
It
state.
is all depending on the. See, it is a very complicated analysis. I am telling you in a very simplistic manner. Suppose in case of a terrain which is undergoing the denudation, it is not that a single rock type is there. It can be can be different type of rock types of different kind of density. Also, the mean elevation, which is again an oversimplification. I am not getting a mean elevation. There can be a drainage area which can have hill, which can have plains, which can have slope. So all these different areas, they have the different kind of denudation rate. I am basically giving you a mean denudation rate, which may not be valid for the entire area. I am saying that it is a oversimplified model, a steady state model. Now, coming on to the sediment which is getting deposited. There can be sandstone, it can be deposited in the form of sandstone, in the form of shale, in the form of carbonate, in the form of evaporite. So everything has its own porosity, everything has its own density. Okay, so a depositional porosity of sandstone is about 40 to 45%. Depositional porosity of shale is about 65 to 70%. So all these porosities, they may be varying, but here you are taking a single porosity. You are considering that all the rocks, they are giving you a new porosity. So I am saying you that that how many analysis is required. How many analysis is required? That is depending upon your prejudice and your experience about the area, that I am basically denuding a area which may have a mean density like this, or their depositional, or I am getting sediments that is being deposited which has a mean density. And neither you are taking a sandstone density, may not be taking a shale density, you are taking a mean density. Similarly, in case of a granite, gneiss, dolerite, basalt, everything can be in your drainage basin, and you are taking a mean density. Am I clear?
Yes, sir.
It is your experience, and then based on that, your expertise, your geological mapping, that the mapping you have done, you have the idea about the kind of rocks exposed in the drainage area, and based on the kind of rock, you are taking a kind of density. Right? Now, if suppose there is another point which I actually not missed, I thought of discussing that with respect to time. Now, time dimension I have not brought. What I am saying that in a particular time this is happening. But who said that whole thing will be balanced over time? There can be any tectonism, and any tectonism will totally change the kind of elevation and the denudation. There can be a extra subsidence in the basin by means of the tectonism again, and the basin, the extra subsidence will cause the more accommodation developed in the basin. So all these that in the time domain it may happen. And then when you have a time domain, there is the different rate that gives way to the generation of the dynamic model. Dynamic model. Okay? So from steady state model, we can do the dynamic model. In the dynamic model, what happens that you basically bring in the effect of time, and the variation in the rate of denudation and the rate of sedimentation with respect to time, so that there is a dynamicity with respect to time. I will not discuss the dynamic model, because the dynamic model actually then people who do that, they divide the dynamic model in some small sectors of steady state model, and say small, and that depends upon the geochronology of the system, that between the two different time planes when the whole thing remained uniform, so you model that. Then the next time slice you have the same uniformity, you model that. So don't compare this from that. So that is becoming the dynamic model. But accordingly, whether steady state model or the dynamic model, you have the whether the basin is a overfilled basin, filled basin, or a underfilled basin. So the basin can be, you got the dynamic model. When it brings the dynamic model,
Yes, sir.
yeah. So tell me that online teaching, and if you would have been in the class, how much the difference would have been in your learning? Anyone, please. Hello? हेलो, नो आइडिया। क्लास में आने से थोड़ा बेटर होता या ऑनलाइन में बेटर है? कोई आइडिया नहीं।
Sir, if we leave the practicals aside, then I think it is almost same. So especially in your case.
Okay. Three different cases. Three different cases. Hello.
Yes, sir.
Yeah. Just listen to me. Then you draw. Three different cases. This is AB and this is AD. This is the denudation area. This is the receiving area. Fine. The basin is subsiding at a rate of 50 mm per million. This is a uniform. 50 mm per million. Fine. The AB by AD, this ratio is 10 here, ratio is 1 here, ratio is 0.1 here. What will be the kind of deposition, how the basin will differ in their response? Yes, yes. हाँ, ये दवाई लिखा है, ये है ना, और इसको थोड़ा सा ना तो लिखवा देना। मैं सुबह गया था सीएमओ से कहा गया तो ये लिखा है, लिखा फिर दवाई लिखी क्या नहीं? हाँ, दवाई लिखी, इसमें लिखना है, दवा इसमें लिखा नहीं ना, वो इसमें लिख देना। ये कौन लिखता है?
मैं जाके देखता हूँ एक बार काउंटर पर देखेगा दवा ठीक है,
हाँ।
लेके चला आऊंगा, नहीं तो सीएमओ से लिखवा दूंगा।
हाँ,
या किसी और डॉक्टर से लिखवा दूंगा।
हाँ, डरने की काउंटर में लिखवा देते हैं, बोलो लिखवा लेना,
ऐसे ही जैसे से दे दे।
दे देना। उसमें नहीं लिखा, तो यही करता है। मेरे को कह रहा है कि बच्चे का थोड़ा कंजेशन था, मैं बोला था थोड़ा चेस्ट देख लो, नहीं सब कोरोना है डॉक्टर साहब, सब कोरोना, जितना लोग खस रहा है ये सब कोरोना भरा हुआ है, डॉक्टर भयंकर है, मैं किसी को नहीं देखूंगा। ये क्या है, ये सब लोग देख रहे हैं, सब डॉक्टर में जाते, ये क्या है, पता है कहाँ से ले आते हैं ये सब डॉक्टर।
इस बार बेटे का यूजी में एडमिशन कराना था प्रोग्राम में, तो उसका ईमेल कॉलेजों को करना भूल गए, वो ट्रांसलेट दस्ती सुना सबने 11 तारीख को बताया, तो जो पोर्टल खुला हुआ था ना वो बंद हो गया।
अच्छा,
तो कल दीप के पास गया, वो गलती हो गई ना कि ईमेल करना, तो अब बोला जिसने के किसी कॉलेज के पास जाओ, प्रिंसिपल जो जानता हो उसके पास जाओ। अगर
कौन सी सब्जेक्ट में करना है?
बीए
में? तो ठीक है, मैं भी बात करूंगा, सिन्हा साहब से भी तुम बोलो, तो मैं भी बात करता हूँ, ठीक है, मैं भी बात करता हूँ।
जैसे कोई सी कॉलेज मिल जाए कोई दिक्कत नहीं।
ठीक है, मैं बात करता हूँ, सिन्हा साहब से भी बोलो, सिन्हा साहब भी बात करेंगे। हाँ, हो गया।
Yes, sir.
Okay. I mean, what I am trying to show you here. This is actually a denudation area, and I am saying that the area of denudation divided by area of deposition, this ratio is 10. Yeah. This ratio is 1 here, this ratio is 0.1. Now, when you have a ratio where the denudation area is 10 times the depositional area, then the amount of sediment that will be delivered, that is so high that it is not only filling the basin, but a large amount of basin that will be actually spilled over to the adjacent basin. It may be spilled over basin. So what will be the character of those kind of basin? They will be mostly continental fluvial basin. They will be mostly continental fluvial basin, and those are the kind of coalland basins. You will see that the coalland basins are always fluvial and fluvio-lacustrine basins, because the associated hinterland is a thrust belt and it has a huge denudation area, but compared to that, the coalland width is much lower. So when you think of the Shivalik and the Himalaya, then what you are seeing, the Himalaya, it is a huge denudation area, but the Shivalik is a very narrow coalland area, and that's why it is not only filling, but the spilling over. The upper Shivalik is a coarse grain, bouldery sediment, and that is basically spilling over to the adjacent basin. So that is a in always I am considering the basin subsidence is uniform 50 mm per mm. Now you are, so these are basically what kind of sediment I expect. I expect sediment will be essentially mechanical sediment, and they will be spillover. Same thing will prevail also when the area ratio is 1. In 1 also, you will get that there will be spillover in the adjacent basin. And so the sedimentation essentially will be mechanical with very less amount of chemicals. Now you come onto this. This basin, where you get the AB by AB is 0.1. That means this area is constricted, this is much larger. So here you start first getting some kind of a marine sediment, suppose a carbonate or evaporite. Carbonate in case of an open basin, evaporite in case of a closed basin. So there you get the first product of the chemicals. So here you will have the overfill basin, same overfill basin, and this is filled basin. Okay? Is it okay?
Yes, sir.
Now there is, you can draw it now. Are the figures visible?
Yes, sir.
Is it done?
Yes, sir.
Okay. So you have drawn the earlier figures, and there I have said that the denudation rate is 100 mm per million. Now I am considering another kind of terrain where you have a 10 millimeter per million. So two types of cases: one 100 million year, 100 mm per million year, another is 10 mm per million. Two different kind of cases because of the different mean elevation of the two different terrains that I am showing. Now, again, I am considering the AB by AB like the earlier one. AB by AB 10 1.1 is the same, that the denudation area and the basin area, their ratio is 10 1 and 0.1. But the mean elevation wise, that terrain is different from this terrain, and that is causing 100 mm per million year. This is causing 10 mm per million. Fine. The deposition, the subsidence rate of the basin, that is uniform. There also the 50 mm per million year. Here also it is the 50 mm per million. So the subsidence rate I am considering same. Now what is happening here? Because of the mean elevation, here you are not getting any overfilled basin. You are not getting, because the amount of sediment that you are delivering, that is only capable of filling the basin, cannot capable of spilling over the basin. It all depends upon the mean elevation what you are keeping there, and what is the denudation rate, what is the volume of sediment that is being generated, and that completely dependent upon the climate and the lithology. These are the two other factors, the climate and lithology and the elevation. These are the three factors which cause the amount of denudation, whether it will be 100 mm per million year or 10 mm per million year. The three factors that control the elevation, climate, and lithology. Elevation, climate, and lithology. And then you get the field basin, then the underfield too. So you start getting the basinal sediment carbonate evaporite right from this stage when the AB by AD that becomes 1. So you get both mechanical sediment as well as the chemical sediment, the basinal sediment. So underfield to field basin, and then you are getting, when it becomes 0.1, you get essentially the underfield basin. There will be very less amount of mechanical sediment. The most of the sediment in the basin, they will be basically the chemical sediment, the carbonate and evaporite. Am I clear?
Yes, sir.
Hello?
Yes, sir.
Okay. So I think this is the thing that I thought of discussing today, that how really the denudation and the deposition, these two are mass-wise that is balanced based on the density and the porosity, and then how the different kind of mean elevation that and climate and lithology that basically considered where the basin will be a overfill basin. The overfill basins are essentially the fluvial basin and the field basin, which may have the component of marine sediment as well as the continental sediment, that is the field basin, and the underfill basins, which are essentially the marine sediment with very less amount of continental sediment or the fluvial sediment, which is basically represented by the marine sediment, that is the carbonate and the evaporite. Right? So this is what I thought of. Essentially, this is the end of your course. That is the on Thursday I will take a half an hour course. Just to summarize what I have discussed, I will start that course at 10:30 on Thursday, and I will take a course only a class of half an hour on Thursday at 10:30 to 11. Okay, is it okay? And that will be the end of the. That will be the end of the course.
Excuse me, sir.
Hello.
Sir, good morning, sir.
Yeah, please.
Sir, can you discuss about the application part of sequence stratigraphy a bit?
Application part of sequence stratigraphy.
Yes, sir.
Yeah, in next class I will discuss.
Thank you, sir.
Okay. Thank you.
Thank
Thank
you,
you,
sir.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.